Hi. So we talked about boosting and the theory behind boosting and why boosting does not overfit. Now, let's look at some applications of boosting to real-world problems. So the first I'm going to show you is research that was done in '98. It's applied research, and the goal was to automate the system that is in charge of directing customer calls to AT&T. So it's called AT&T, How May I Help You? And basically it classifies the voice requests and has to send them to the right category of answers. Okay, so the way that it was done, it's that the voice was transcribed into text, and then the text was mapped into a category. And boosting was used to do the mapping from text to category. There were 14 categories: area code, AT&T service, billing credit, calling card. Some of these are really aged, so there's no more use of calling card or of collect, competitor, and then dial assistance, directory, how to dial, person-to-person, rate, and third party, and time charge. Okay, so these are the categories that were supposed to be mapped to. And here are some examples of sentences that were uttered by the customer and how they were mapped. So, yes, I'd like to place a collect call, long distance, please. That is for collect. Operator, I need to make a call, but I need to bill it to my office. That's third party. And yes, I'd like to place a call on my MasterCard, please. That's calling card. Finally, I just called a number in Sioux City and I must have rung the wrong number because I got the wrong party and I would like to have that taken off my bill. That's billing credit. Okay, so sometimes the information about the right category is really hidden in there. However, we're going to use a pretty simple type of classifier that just looks for words that are indicative of what this should be. So let's see what are the words that were, what are the weak rules that were used by this program. By the way, it's called BoostExter, and you can Google for that and you can find the software. And the weak rule was simply a word, whether the word appeared or did not appear. And here are the different words or combinations of words. Okay, so the first row for each word indicates the information you get about if the word appears, and the second one is if the word does not appear. So the first that we're looking at is the category collect call, and we see that the word collect is a weak rule that indicates that this is a collect call. And similarly, calling card, the word card is a good indication that this is a calling card. And finally, my home is a combination of words that appears a lot if this is a third party. Okay, so this is basically the words that were chosen as weak rules. And of course, there were many, many thousands of words, and only a small handful of them were chosen. So what were the results from doing that? They had about 7,800 examples, and they were hand transcribed. And then they had 1,000 test examples, and some were hand transcribed and some were machine transcribed, or they both had machine and hand transcription. And the accuracy that they got with 20% rejected, so 20% you're saying, I don't know what that is. If it was machine transcribed, it was 75% accuracy, and hand transcribed, 90% accuracy. So pretty good. Here's a second application that I worked on. This was also in AT&T, and the problem that we had was to distinguish residences from businesses, different types of customers. And this was done using statistics from call detail records. So AT&T would collect all of these records about who called who, and from that they wanted to know, is this a residence or is this a business? And we used alternating decision trees that I described before. And the data set were pretty massive. Okay, so there were 260 million calls a day, and there were 230 million telephone numbers that we wanted to classify. And we didn't know the label for about 30% of them. So we used some special software to quickly gather statistics from these call detail records. And then to train our classifier, we just used 100,000 randomly selected training examples. And it turned out that that was more than we needed. About 10,000 was enough. So training took about 2 hours, and it generated a classifier that was both accurate and efficient. It had to be efficient because you had to apply it to all of these 230 million telephone numbers, even though you trained it on a small fraction of that. So here is the alternating decision tree that was generated. So as you see, it's pretty big. But if you look inside the tree and you look at some details, then you see that it actually makes sense. So for instance, it says if this telephone number makes more than 14.5% of its call on weekdays, where the time of day is between 6 p.m. and midnight, then that's likely to be a residence. Okay, so what you see here is that the features that we used were very, very detailed. They were a combination of whether the call went in or went out, what time of day it was, what day of the week it was, and so on. So many thousands of features, and from those, Boosting chose a handful that gave us good predictions. And this is the precision recall graph that we got. This was the blue and the red are the precision recall graphs of the systems before, that were used before. That was a system that had a separate classifier for incoming and for outgoing. And here is the performance of our classifier. So you can see that it is clearly better. The interesting thing is that this had a significant business impact. So this is one of those things that only when you can see the business case for them, you can understand why they're important. So the coverage we got improved from 44% to 56% for a fixed accuracy of 94%. Okay, so we improved by 12% the coverage. Was that useful? Was that meaningful? Well, yes, it was. It turned out that it saved AT&T about $15 million in the year 2000 alone in operation cost and missed opportunities. Okay, so when you have big operations of large corporations, you get big improvements even if you just improve things by a few percent. So next I'm going to tell you about face detection, which is one of the more interesting applications, and we'll continue from there. See you then.